Hello everyone. Today I'm going to talk about Docker basics. My name is Riju and here is my Twitter handle. So let's first understand some of the basic stuffs of Docker. So teams today must release apps quickly to attract and keep businesses. That's the requirement. And that forces the software development and support teams to always look at solutions that save time and reduce cost. An ideal solution will reduce the time spent on creating and configuring deployment environments and simplify the software deployment process. The idea of using software containerization technology as a time saving and cost reduction solution is popular. One of the strengths of containerization is that you don't have to configure hardware and spend time installing operating systems and software to host a deployment. Containers are isolated from each other, and multiple containers can run on the same hardware. This configuration helps us use hardware more efficiently and can help improve our application's security. Suppose you work on a on an online clothing retailer that is planning the deployment of several internal apps. Your team develops and tests all applications on premises and then deploys them to Azure for pre-production testing and final production hosting. You're looking for some maximum cap compatibility on each environment with a little or no configuration change. Using Docker as a containerization solution seems an ideal choice. So let's learn how Docker is used to create our own containers, and then we will learn how Docker infrastructure works behind the scene. And the goal here is to help you decide whether Docker container is the right choice for your solution or not. Now, what is Docker? Before we start our this quick tour of Docker container, let's have a look how team develops and deploy applications. The process of developing and managing applications in your company typically includes one or more teams. There is a development team that creates the software and an operation team responsible for the deployment of those applications. The operations team is also responsible for management of the application hosting infrastructure. For example, assume we are developing an order tracking portal that our company's various outlets will use. Several environments host our applications during the app development and publish process. First, the development team develops and tests the software in a development environment. From here, the software then deployed to a quality assurance environment or test environment, followed by pre-production and then final production environment, right? So the managing and hosting environment is difficult. The different environment all requires both software and hardware management. We have to ensure that both the installed software and configured hardware in each is the same. We also need to configure aspects such as network access, data storage, and security per environment, which is consistent and easily reproducible in manner, right? Continuity in software delivery is also the key aspect to it. Deployment of an application to our environment must happen consistently. Each deployment package must include all system packages, binaries, libraries, configuration files, and other items that will ensure fully functional application. We also need to make sure that all of these dependencies match software versions and architecture. Efficient use of hardware. Each deployed application must execute in such a way that it is isolated from other applications running on the same hardware. We aim to run more than one application per server to make the best use of resources without compromising each other. Application portability, etc., are also part of that. Now, we understand that we can put things in a container. So it's a software package that includes code, all dependencies, and run application quickly, right? And Docker is one such container runtime environment which runs on top of operating system. So Docker basically is a containerization platform used for to develop, ship, and run containers. So Docker does not use hypervisor, and you can run Docker on desktop or laptop if you are developing or testing applications. The desktop version of Docker supports Linux, Windows, and Mac OS. For production system, Docker is available for server environments, including variants of Linux and Microsoft Windows Server 2016 onwards. Many clouds, including Azure, supports Docker. Now, Docker platform consists of several components that we can use to build, run, and manage our containerized application. One is Docker Engine, which is the key component, which consists several components configured as a client-server implementation, where the client and server run simultaneously on the same host. The client communicates with the server using REST API, which allows the client to also communicate with the remote server instances. Docker also provides Docker client, generally through command line interface, which we will be using now onwards. And it can interact with the Docker server. Docker command uses the Docker REST API to send instruction to either local or remote server and functions as the primary interface we use to manage our containers. Now, let's jump into the Docker machine, right? So what I have over here is that I have a Linux machine running and I install Docker. So I'm using Ubuntu machine, and in this machine, I just say apt get install docker.io, and it installed. So you can follow based on whatever operating system you are using. And I'm using Community Edition because I'm using the free version. So, and one of the things you need to remember that Docker uses the operating system kernel. It doesn't block the setup RAM and CPU, etc., which ideally is happening in the virtual machine or hypervisor kind of scenario. Now, let's imagine that you have got the Docker installed, right? So to check whether Docker is up and running, you can see first whether Docker CLI is installed. So if you do that, it shows you all the commands you can run. So which means the Docker CLI is installed. If you say Docker PS, that will show you all the images. So there is no image, so it's clean refresh. So we do not have anything at this point in time. So which means that it is all looking fine at this point in time. So we can just start working on it. We can even check what all images I have in my local machine. So I can say Docker images, and it'll show you all the images I have in my local machine. So I'm using Minikube for Kubernetes testing purpose. So you can see the Minikube images is already downloaded, but I can actually run other container, and then if that requires different images, it will download those images as and when required. So we'll first understand the concept of image. So basically, Docker software automatically configures the local image registry on your machine, which means that it basically contains the required files and runtimes you may need for your application. So the image basically is uh, sort of like you can think of package solution, right? And every Docker container, just remember this, every Docker container can run one single process. Now, that's what the job of the Docker container is. And we'll see how we can run a Docker container. And one of the test Docker container check, which is given in the Docker documentation, is that once you have the Docker installation is done, you can see just run Docker, let's say Docker run hello. So what it's just basically going to do is that sudo docker run hello. Sorry, unable to find Docker isn't. Okay, so we do not have that. So I'll say Docker run Ubuntu. I can see that when I say Docker run Ubuntu, it goes ahead and tries to find the Ubuntu image, whether it's available below my local machine. And when it doesn't find that, it goes ahead and downloads the Ubuntu image. And you can see that there are various different layers of the Ubuntu image. We will not go very deep into it, but you can imagine that as and when there is a new thing required, you just add a layer. You don't need to upload that. So from where this is coming? This is coming from something called Docker Hub. It's a location where these images are available and it downloads as and when you ask. So you can have your own registry or hub and you can download it from there. You just need to log in from the same CLI and it'll start downloading from there. If you don't explicitly mention the fully qualified URL, it'll download from the Docker hub. Okay. Now this is what is done. Now if I say Docker PS, what I will see nothing, because what happened actually is that it downloaded, it ran, and it stopped because there is nothing much to do. So let's see what is there, Docker PSA. It shows you all the Docker, all the containers which ran and then got killed or exited. So you can see that it ran something called Ubuntu machine, right? I sometime ran it for some 15, 20, 52 seconds ago, most recent one, and then it just stopped. Okay. Now I want to continue running this Docker. Now, if I do a Docker run Ubuntu, and then I say I give a name as my Ubu. Um, do I say so? You can always use the help command. So I'll say Docker run help, and it should show me whether I can pass on. I just want to give a different name so that I can identify that. The image run options image command. So the option says that name. Okay, so let's just put the name before. So I say Docker run name Ubuntu and then Ubuntu. That means it'll now run Docker image. But if you just now see that nothing happened much, right? Same thing. You can see now second image and the name my Ubu. So it basically took the whole thing as a name. So I can only pass probably just the name. So you can see that the second image got created, the second container got created and exited. But I want to stay there. I want to do something to make sure that I am there. So if I run this, okay, and then say I want to, let's say, do this, Ubuntu, my Ubuntu minus IT, and I'll talk about it. What is this IT about, right? Oh, no, 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 no. So I just wanted to execute that IT. No, what I wanted to do is that I wanted to continue running this. So instead of doing that, what I will do probably, I will run this Ubuntu machine in a daemon kind of thing, which means it'll keep running in the background. Now, notice here, if I say Docker PS, I should be able to see 12-second, 11-second, it got exited, Docker ps should show me that. Huh, it shows the value, which means that it should be running in the background, right? So what happens when you run a container, right? And if you run a container with -d, um, I don't want to do a sudo, so I am doing sudo. I don't understand. So yeah, so I say docker ps -a. So you get to see, let me just reduce the size of the screen, get to see this, every Docker container I'm creating, right, gets a name. Even if I'm not providing the name, it gets a name. So what happens if I, let's say, uh, want to delete some container, huh? So if I say Docker rm, and then I say funny ride, if I do that, then the funny ride container gets deleted. So if I now do a Docker ps -a, Docker ps -a, it basically goes ahead and deletes that funny ride. If I want to, let's say, delete Docker, okay, so Docker rm, and then I delete, let's say, some other container, I can use the container ID also. So that is competent ELO. That's the name of the container. So let's put that ID, and you can see that that gets created. Another quick option is to run the partial, let's say, ID value. So imagine that I want to delete, let's say, this one, which has got D11. So if I say D11, should be enough for me to delete that container, just to verify Docker ps -a, not L, A, I do not have that container available, so it got deleted. So I do not need to provide the full ID. I can provide the partial ID. So I can say RM, that is remove 1B7. Okay, if there is a repeat, then it won't. But if there is only one container with that initial three characters, it will delete that. So you can say 303 and it will delete that. So if you just run Docker ps -a, you will find only few containers. So you should be cleaning up your machine space. Remember that if you don't clean up, it all gets piled up, so which will take a lot of space in your machine. So you can go ahead and delete a container as you keep working on something like that, right? So if there is a container which is kind of running, right, you can see that there is a container which got created, which is created. So if you uh, want to attach that and then run it, right? So you restart a container, you can say, I want to restart a container. So let's take Quizzical Beaver. Okay, so let's copy this and I say Docker restart the container name. Okay, do that. I cannot restart the container, failed because executable file not found in the path unknown. Okay, so it did not get executed, right? So I I can use Docker run reju ubuntu, and then it will, I say dash name Docker ps -a, you will find that new container available. And then if I say Docker restart reju, and it got restarted, and Docker ps -a, so -a will show up that container exited 19. So it basically tries to open the bin bash, right? And it could not do that, and hence it went ahead and stopped that. You know how to stop a container. It is fairly simple. So you say docker stop and then the container name and which will be stopped. Right? It's already a stopped container. That doesn't change a much. But if that is running, let's say I want to stop the container. This one that is B984. B984. Okay, and then if I just run this, you will notice that B984 is kind of stopped. So it is already stopped. So that's doesn't change a lot. So you can run these things one after another to really control the container behavior, right? So what I basically wanted to talk about here is that once you have the Docker runtime installed, the Docker CE installed, right? So you have all the Docker container images up there available for you to use. So there are many different images you can download and use. You can run a container like let me just increase the font size so that it is visible to all of us in a clear manner. So if I say let's clean this up, Docker run, and then I want to run it in interactive terminal, that is IT, and then I say Ubuntu, then it won't download again, and then I use the bash command. That's the command I want to use. So it starts the container and opens the bash command. So I can say ls and it'll show you all the files. I can add a file into that. So I can say that, hey, I want to create a file. So I'll say touch hello, and then hello will be spelling mistake. So there will be a file, new file created. You can say help is created, and then it is all inside the container. So I can say Control C, Control X, Control P, Control Q is what I can come out of that. And I say Docker PS, and it shows you the container which is running, right? That's the Ubuntu container I was in. And if I want to go back to the same container, I say Docker attach, and then attach the container running container that is 605. Okay, and you go into the same container again. If you say ls, and you see that help file is there, so which means I am back to the same container. I can start working against. So if you, let's say, use another control P control Q will not exit, but if you let's say do it again and then say control X, control C, or you say exit, it basically comes out. Now if you say docker ps, you won't find that container running anymore because you have exited. I want to show you one more time. You just run this ubuntu bash and run ps, and you will see that it runs one single process, that is bash. So no other process is running. Once this process is over, that means you say exit, it exited the container, and then it shows up in the dead container list. Again, I'm typing mistake. So dead container list, you can see that it shows up in that. So if I download some other container instead of Ubuntu image, let's say I want to use a BusyBox. So if I say Docker run busy IT, that is interactive terminal, busy box, and I say bash. It doesn't have bash, it has a sh. Docker login, why this is not showing up? Run interactive busy. Yeah, so the busy box got downloaded, and you can see that now I'm in the interactive terminal of the busy box, and I see it. So if I say Control P, Control Q, it comes out, but it keeps running in the Docker as a container, you can see the busybox is running with the command sh, which is a shell command for busybox. It's a minimal installation. So if you want to install, you can say sudo blah blah blah, and it will install things. So you can do all sort of things while you start from a basic container and then move on, right? One of the things I wanted to also show you is that you continue to get this thing piled up in your list, right? All the things. So if you want to, let's say, delete all of them, you have to keep deleting, right? Docker rm, and then you say 517, and then you say bd7, right? So you just need to delete them. And what basically is more important is that you need to make sure that your machine space is available, right? So I can even say 9b, I will delete the 9b, and I say b. You can see that there is a conflict with b, right? So the b is, there are multiple containers, so I need to identify again with b, not b4. So I will say that I will b9, I will delete b9. So it will delete that. So I'll say docker ps minus a, and it shows you that now we have got docker rm b4 a5 a5 517 517, and they are kind of getting deleted, right? So if I say now docker ps minus a, it'll show you only two containers in this machine. Now, you don't want to do all the time. If you want to, let's say, have a container run in and then remove it automatically once that is done, you can use dash dash rm command to do that. So let's see how that looks like. So if I say docker run dash dash rm ubc box it, sorry, interactive terminal busy box sh. I say ls control p control q and docker ps. It'll show you the busybox sh running, right? So the 038 is the busybox sh. If I say docker attach and then say what is the name of that, so I'll use 038, right? And I attach that and I say ls and I exit from this. What happens here this time? This time docker.ps minus a will not show this container. So you won't find 038 because rm is, till the time you are using that container, it will be there and it will be automatically cleaned. It's a convenient way to use the container. Otherwise, you have to keep deleting. And there's a way to also loop through the container list and then delete all of them. But I don't want to do that because I have got my Minikube running, which will also delete that Minikube image, which I don't want to do at this point in time. Right, so there are a couple of advanced topic with the Docker, which I don't want to touch on. But what I really mean to say is that you can play around with that and follow along the Docker documentation. There are many different, let's say, components and things you can do, right? So you can play around with with Docker, play around with the networking, storage, etc., and see how these things really fits into the picture, right? So with this, I wanted to end, but I want to also run one more command, images, to see what all images. Now you see that I have used both BusyBox and Ubuntu. They all get here, and they are not very big, like 72 and 1 MB, but imagine they are GBs in size. So I need to remove them also. So to remove the image, you say rm image, that is RMI, and then say BusyBox, and there is an image ID. Let's use that image ID. That is 4911. image is being used. So what I need to do is that I need to first clean up the container and then clean the image. So before that, I let me remove the Ubuntu, which is more uh, bigger, right? So let's say I delete this, and you can see that the Ubuntu got deleted. So if I now use Docker images, I will only find the busy box. So what I need to do, I need to first stop the container, delete the container, and then delete the busy box. If I use the dash dash force command, then it will be forcefully deleted, but I don't want to do that. So that's all from my side. Hope you enjoyed, and it is a vast topic, but I tried to cover what is most important for you to play around with Docker. Thank you very much. Have a wonderful day.